Let's do some problems with exponential functions. Exponential growth and decay. So let's see. The inflation is 3.7%, and you know that's going to be going up, right? So you learned in pre-algebra, compound interest. Oh, it's kind of hard to write with my mouse. Okay, compound interest formula is the amount is P, I say times 1 plus or minus the interest rate raised to the T. P is the principal, so like the starting amount. A is the amount after the T number of usually years typically. This is the percentage rate. And then you do 1 plus or minus the rate. Because if it increases by, let's say, 0, let's say it raises by 5%, that would be 1 plus 0.05. So it would be 1.05. And that is basically saying like 105% of the amount. After 1 year, it's 105%. And then after another year, it's another 105% of that amount. And then another year, it's 105% of that amount. And it keeps growing at that percentage rate, compounding. So it actually ends up growing like this over time. That's like the value of saving money. Okay, so for this one particularly, it says we're starting with $3,000. We're going to multiply, it's going to go up by 3%. That was 1.37. It's not decreasing by 3% because then that would be 1 minus 3.7%. So then it would be like 0.963 or something like that. And raised to the T. So it says 10 years. That's going to tell us 10 years from now. The current price, though, is that just that first number. So let's just do a bunch of these. So this is 3,000. And 10 years from now, I'm just going to go, let's say, 3,000 times. I'll even do the parentheses 1.037. I'm going to raise that to the 10th power. Bang. And I'll just press solve, and that's what we got. Let's try another one. Perfect. It is currently 600, but with inflation, I can actually do it like this: 1.034 raised to the 9th gives me this, and then multiply it by the original amount. Press enter, 810.66. Oh, raised to the nearest dollar. Okay, fine. Guess we got to pay attention to that. Nearest dollar. Okay. So now that the value of a car is depreciating, it's going down. So right now when we bought it new, it was $25,900, but it's going to decrease by 8% each year. So now it's 92% of that. So after 1 year, it is going to be 0.92. So after 1 year, it's this times 0.92. It keeps going. I wonder if I can keep going. It won't let me. Okay. So let's just do, well, 8% decrease for 12 years is actually going to be, oh my gosh, such a huge amount of decrease. So times 25,900, bang. Now it is worth $9,523. Bang. Did it. The next concept we have is half-life. And that's kind of telling you how long it takes to half. So right now, the initial amount is 621. And 80 years is halving one time, two time, and then a little bit more than that. So that is, we'll just do 1/2. Oh, could do this. Boom, click off. I'm going to raise this whole thing to the 80/30ths. Okay. So we can have this thing and then times 621. Give us 97.8. Nearest gram, 98 grams. Okay. One more. Perfect. This is 14 hours, so after 40 hours, so it's decaying over time. We know it is initially 1200. After 40 hours, I can actually just type the whole thing just to show you it still works. Go right, boom. What if you just, like, can we copy paste that? No, okay. To the 40 over 14. We don't have to simplify, it's going to do it for us. So that's 166. Check it. Bang, you know it's right. Okay, I'm sure that was helpful. Go ahead and try a bunch of this stuff, and eventually they're going to give you some different types of problems. So anything with exponential functions, things that grow exponentially, like savings, or decaying, like cars, that's going to be good context for you to practice. Keep it up. Good job.